Your dog is asleep on the couch, legs twitching, a soft whimper escaping, and you are sitting there wondering what is going on in that head right now. Is he running? Is he chasing something? And then the thought creeps in, the one every pet owner has had at least once: is he dreaming about me? It sounds like a soft question, a sentimental one, but it is actually one of the most fascinating intersections of neuroscience and animal behavior that researchers have spent decades trying to answer. And the answer, once you actually look at what the science says, is stranger, warmer, and more interesting than you probably expected. Because here is the thing. The brain your dog or cat is running on right now, while they twitch and whimper on your sofa, is not so different from yours. The architecture is older. The processing is different. But the sleeping brain, the dreaming brain, operates on machinery that goes back hundreds of millions of years. And that machinery does not care much whether the creature running it has 4 legs or 2. So let us get into it. What is actually happening when your pet sleeps? What they are most likely dreaming about? And yes, whether you are in there somewhere. Subscribe to Freud Mind for more of this kind of thing. Now let us talk about your sleeping dog. First, the question of whether animals dream at all, because for a long time, this was genuinely contested. The assumption for much of scientific history was that dreaming was a uniquely human experience, something tied to our complex consciousness, our language, our narrative self. The idea that a dog or a cat was having experiences during sleep felt too close to anthropomorphism, the tendency to project human qualities onto animals that scientists were always careful to avoid. Then came the research that changed everything. In the 1960s, a researcher named Michel Jouvet began studying sleep in cats and made a discovery that would quietly reshape how we think about animal minds. He found that cats, like humans, cycle through distinct stages of sleep, including a stage now known as REM sleep. REM stands for rapid eye movement, and it is the stage most strongly associated with dreaming in humans. During REM sleep, the brain becomes highly active, almost as active as when you're fully awake, while the body is largely paralyzed. That paralysis, researchers believe, is a protective mechanism. It stops you from acting out whatever your brain is experiencing. Jouvet noticed that when he temporarily disabled the region of the brain responsible for that paralysis in cats, something remarkable happened. The sleeping cats got up and moved. They stalked. They pounced. They appeared to hunt invisible prey, fully asleep, but physically enacting what they were experiencing internally. They were acting out their dreams. This was not a cat being weird. This was a window directly into a sleeping animal's inner life. Subsequent research confirmed that virtually every mammal studied, dogs, rats, dolphins, horses, primates, shows REM sleep. Birds show it too, though their REM cycles are very brief. Even some reptiles show signs of sleep states that resemble it. The capacity for this type of sleep is ancient. It predates humans by an enormous margin. And if REM sleep in humans is where dreaming happens, the most straightforward interpretation of the evidence is that dreaming, in some form, is happening across a much wider range of species than we ever assumed. The most direct evidence for animal dreaming came from work done at MIT by neuroscientist Matthew Wilson and his student Kenway Louie in 2001. They were studying rats, and they did something ingenious. They recorded the specific patterns of neural activity in the rat's hippocampus, the brain region central to memory and spatial navigation, while the rats ran mazes during the day. Then they recorded the same neural activity while the rats slept that night. The patterns matched, not loosely matched, precisely matched, to a degree that allowed the researchers to identify, with reasonable confidence, which specific section of the maze a rat was replaying in its sleep. The rats were not just sleeping. They were running the maze again, reviewing the day, processing the experience. And they were doing it in the same brain region that handles memory consolidation in humans during sleep. This is significant for two reasons. First, it confirms that animal dreaming is not random neural noise. It is structured, it is memory-based, and it appears to serve the same function that researchers believe dreaming serves in humans: consolidating experience, processing information, filing the day's events. Second, it tells you something about what your pet is likely dreaming about. They are dreaming about their day, about what they did, what they saw, what they experienced, about the things that mattered to their brain while they were awake. And for a dog, what matters while they are awake? You, the walk, the meal, the sound of your voice, the specific person who represents safety, food, play, and the emotional center of their entire social world. Dogs are a fascinating case because of how deeply they have co-evolved with humans. No other animal on Earth has spent as long, somewhere between 15 and 40,000 years, depending on which research you follow, living in close daily contact with people. That coevolution has produced a brain that is, in some specific ways, extraordinarily tuned to human beings. Dogs can read human facial expressions with a level of accuracy that researchers find genuinely surprising. They follow human pointing gestures in ways that even our closest primate relatives, chimpanzees, do not naturally do. They look to human faces for information when they are uncertain about something. They have developed a muscle above their inner eyebrow, a muscle that wolves do not have, specifically for making the expression that humans find most appealing and most readable as emotional. This muscle exists, researchers believe, because dogs that could communicate more effectively with humans were more likely to survive and reproduce over tens of thousands of years. What this means is that when your dog looks at you, they are not doing what a wolf does. They are not calculating your threat level or your resource value. They are doing something closer to what you do when you look at someone you trust. They are reading you. They are relating to you. The bond is not imagined. It is neurological. It is written into their biology after millennia of proximity to ours. So when a dog sleeps and their brain cycles back through the significant events of the day, the faces, the smells, the sounds, the interactions that mattered, you are almost certainly part of that content, not in the way you dream, with narrative and language and strange symbolic transformations, but in the sensory, emotional, associative way that a brain tuned to your presence would naturally replay you. The smell of you, the sound of your footsteps, the specific feeling of the interaction you had that morning. Now let us talk about the twitching, because if you have watched a dog or cat sleep, you have seen it. The legs paddling, the face scrunching, the tail flicking, the little muffled sounds. It looks almost too perfect to be real. It looks exactly like a dog running, or a cat hunting, or whatever it is they do when they are fully awake and excited. That is because, neurologically, it essentially is. During REM sleep, the brainstem sends signals that paralyze the major muscle groups. This is the same mechanism Jouvet discovered in cats. But that paralysis is not perfect. It does not cover every muscle equally. Small muscle groups, the face, the paws, the tail, can break through. And when the dreaming brain sends motor signals, run, jump, pounce, wag, those small muscles respond. The result is the twitching you see. In puppies and kittens, the twitching is often much more dramatic than in adults. Researchers believe this is because the brainstem paralysis mechanism is not yet fully developed in young animals. The break is not as strong. This is also why human babies twitch more dramatically during sleep than adults do. The system is the same across species. The young versions of all of us are looser sleepers with more physical expression. The sounds, the whimpers, the small barks, the chirping sounds cats make, the chattering teeth, follow the same logic. The vocal muscles are small enough to escape the REM paralysis. And when the dreaming brain activates whatever emotional or communicative circuitry is running, small sounds slip out. A dog that makes a soft bark in its sleep is not just making noise. The same neural pathways that produce barking when awake are being activated. Something in the dream warranted a bark. What about birds and fish? Because not every pet owner has a dog or cat, and it is worth being honest about where the science stands on other animals. Birds are genuinely interesting here. Several species, including zebra finches, have been observed replaying their songs during sleep. The same neural patterns that fire when a bird sings during the day reactivate at night while they sleep. Researchers believe this is how birds consolidate and refine their songs, practicing them in sleep the same way a human musician might mentally rehearse. Whether birds have vivid dream experiences in any meaningful sense is harder to say. But the memory replay mechanism is clearly there. Fish are a different story. Fish do sleep. They have rest states with reduced activity, slower breathing, and decreased responsiveness to stimuli. Some fish even float almost motionless or wedge themselves into a corner or crevice in a way that looks very much like sleep behavior. But whether fish have anything resembling REM sleep or experience anything during those rest states that could be called dreaming is genuinely unclear. The brain architecture is different enough that the comparison does not map cleanly. What researchers are fairly confident about is that fish rest, that the rest matters to their functioning, and that more complex fish likely have more complex rest experiences than simpler ones. Beyond that, the honest answer is that we do not fully know. What about nightmares? This is where it gets a little more emotionally loaded, but it is worth taking seriously. If animals dream by replaying and processing their experiences, then an animal with traumatic or frightening experiences in its history will have that material available in its dreaming brain. Rescue dogs, dogs that came from difficult backgrounds, that experienced neglect or fear or instability before finding their home, are often observed having what appear to be distressed sleep episodes, louder vocalizations, more agitated twitching. The kind of sleep behavior that, in a human context, you would associate with a bad dream. Whether this constitutes a nightmare in the rich, subjective sense that humans experience them is genuinely unknowable. We cannot get inside the experience, but the behavioral evidence is consistent with what you would expect if the animal were processing frightening memories during sleep. The brain does not distinguish between human and animal when it comes to the emotional weight of experience. Fear is ancient. The circuitry for it exists across species. And if that circuitry fires during sleep in response to fearful memories, the experience, whatever it is like from the inside, is probably not pleasant. What can you do if your pet appears to be having a distressing dream? The instinct is to wake them up, and it is a kind instinct. But the guidance from animal behavior researchers is to think carefully about how you do it. Abrupt waking from deep REM sleep is disorienting for any mammal, including humans. And a dog, startled out of a dream, can react before the waking brain has fully taken over. The safer approach is to speak softly near them. Use their name, use a calm tone, and let the sound of your voice bring them up gradually, rather than reaching in and touching them suddenly. The voice works well because it is the most familiar, most trusted sensory signal. It anchors them back to the waking world through the thing that means safety. And in most cases, within moments of waking, they find you. They look for you. They readjust to the real world, using you as the reference point, which tells you something. Cats dream too, though cat sleeping behavior is its own interesting territory. Cats sleep far more than dogs, anywhere from 12 to 16 hours a day in many cases, with some cats sleeping even more. This is partly because cats are evolved hunters, and hunting is energetically expensive. The deep rest between hunts is how the system recovers. A cat that appears to be doing nothing most of the day is, from a biological standpoint, doing exactly what it should be doing. Cats show clear REM sleep with all the associated signs: rapid eye movement beneath closed lids, whisker twitching, paw movements, occasional vocalizations, the chattering sound cats sometimes make in their sleep, the same clicking, chattering sound they make when they watch birds through a window, is thought to be connected to prey-related dreaming, the brain activating the hunt circuitry, the jaw going through the motions of what it knows. The relationship cats have with their owners is different from dogs, but no less real. Cats are often characterized as independent and indifferent, but behavioral research tells a more nuanced story. Studies have found that cats show secure and insecure attachment patterns to their owners. The same attachment framework used to describe human-infant caregiver bonds. Cats with secure attachment are calm in their owner's presence and use them as a safe base for exploration. Cats with insecure attachment show anxiety and distress patterns that mirror what you see in humans with anxious attachment styles. Cats also recognize their owner's voice specifically. They respond differently to their owner calling their name than to a stranger doing the same thing, even if they choose not to show it, which, genuinely, is very on brand. The recognition is there. The preference is there. Whether you feature in their dreams the way a dog dreams about you is harder to say. Cats are more solitary hunters, and their dreaming content may skew more toward prey and territory than social bonds. But you are certainly part of their known world, part of the sensory landscape their brain has filed under significant. There is one more dimension to this worth considering: what your pet actually understands about you when they are awake, because it connects to what they might carry into sleep. Research on dog cognition has found that dogs have a working vocabulary that can reach into the hundreds of individual words for highly trained dogs. But more interestingly, that all dogs process the emotional tone of human speech with a level of sophistication that surprised researchers. A 2016 study using brain imaging found that dogs process both the meaning and the emotional tone of words separately in different brain hemispheres, in a way that broadly mirrors how humans do it. Praising words delivered in a flat tone did not activate the reward center. Neutral words in a praising tone activated it partially. But praising words in a praising tone, the combination, lit up the reward center fully. They are not just hearing the music of your voice. They are hearing both the music and the words simultaneously, and smell, which is the sense that dominates dog cognition in a way humans find almost impossible to imagine. A dog's olfactory cortex is proportionally 40 times larger than ours. They do not just smell you when they arrive in a room. They smell your emotional state, your health markers, how long ago you were there, whether you are the same today as you were yesterday. You are not just a face and a voice to your dog. You are an enormously complex, constantly updated, deeply familiar scent profile that their brain has been building since the day you met. When that brain sleeps and replays its day, that scent profile, that extraordinarily detailed sensory record of you, is part of what it is working with. You are not just in their memory. You are woven through the entire sensory architecture of how they experience the world. There is something quietly meaningful in all of this. The animal asleep on your floor or your couch or pressed against your legs is not just resting, it is processing. Its brain is cycling through the day, consolidating what mattered, filing what was significant, replaying what its nervous system needs to review. And in a brain that has co-evolved with yours, that has been shaped over thousands of years to tune into your face and your voice and your presence, what is significant tends to involve you. You are not just their owner. You are their primary reference point for safety. When they sleep well, it is partly because that reference point is close. When they startle awake from a dream, the first thing many of them do is find you. With their eyes, with their nose, with a quick look to confirm you are still there, and when they settle back down, they often press a little closer. That is not sentiment. That is attachment behavior. The same neurological system that drives human infants toward their caregivers when frightened. Ancient, cross-species, real. So the next time your dog's legs start paddling in their sleep, yes, they are probably running somewhere. And given everything the research suggests about what matters to a dreaming animal brain, there is a reasonable chance you are somewhere in that dream. Not as a thought or a concept, but as the smell of home, the sound of the voice that means safe, the presence the sleeping brain returns to when the day is done. Subscribe to Freud Mind for more.